I got a live stream going. Nobody's logged in yet. Oh, you just dropped it over there. Don't put it there. Why do you put stuff there? Somebody's there. Oh, we actually got somebody. Cool. Let's see if I can get this thing going. Welcome to the live stream. Just kind of started waiting for a few people to show up. Any questions? I got the live chat open. I'm just going to get a couple other things here. I'll be right back. Angela, the popcorn fell again.
Animal.
Just kind of get things set up here. Capacitor. Any questions? Just live chat's open. Just let me set up here. I'm going to talk about the proximity sensor. Seems to be a little bit of a controversy with this proximity sensor that I used to trigger the motor. So we'll get that sorted in. And then we'll move on because I know somebody's been kind of questioning me a lot about the proximity sensor and the effect that I'm getting with it. So I kind of want to set the record straight. Doing a live stream. I got my rigs here. Any questions, comments? Live chat's open. We'll talk about the transducer, the barium titanate transducer. They're used in what I call ultrasonic cleaners. So we can talk about that too. Spark gap switch. Yeah, so just kind of getting set up here. Bear with me. look everything up. I just want people to understand my circuit, why I'm doing what I'm doing. So, because people keep using the damn MOSFETs and seeing those drive me nuts, literally. I'm not a fan of the MOSFETs because you'll never get the disruptive discharge that Tesla's been talking about all along. That's the key to making these systems get into over unity. And if you're using a barium titanate transducer, you need the disruptive discharge in order to make it happen. Because usually transducers, they're activated by stress. So if you crack it, hit it with a hammer or anything like that, it creates voltage. Instead of using that, I'm hitting it with a high voltage spike. That reaction's getting me a way higher potential coming out. So instead of using the physical stress or hitting it with a hammer or stepping on it or pressing it with your finger, I'm using a high voltage discharge spike from the coil, and the disruptive discharge creates that snap, and that snap is what activates the transducer, and that's where the overunity happens. So this capacitor bank I'm using is 16 volt, 500 farad. These guys, you buy them on Amazon. So in the last week, I've been experimenting with, it's called dielectric absorption. So when you discharge these down to zero or close to it, they will rebound, meaning that mysteriously voltage comes back into the capacitor, and that's coming through the the dielectric field that's in between the plates inside the capacitors. Any questions, comments, live chat's open. Feel free, don't be shy. Any questions on the topics that we're going to cover tonight? We got people coming and going right now, so I'm just going to hang out here, get things set up. And yeah, so when I get everything hooked up, then I'll start running the motor for a bit just to kind of get it running. Okay, so right about that. Oh yeah, I need 2 cables. I'll be right back. Zushka, why don't you have the sushi right? Zushka, don't be shy. Okay, back. Sorry about that. Just had to grab a couple of cables. Get this hooked up. Yeah, I don't know if he's doing a stream tonight. I don't know. He's been a little erratic lately on doing streams. He's all kind of all over. I need a voltmeter. I'll be right back. Voltmeter. set up. Any questions? What's that? Sanjik. Sorry if I'm killing your name. Any questions on what I'm doing? .47. So right now in the cap bank, I got 2.47 volts in the capacitor bank. So what I'm going to do is I'm going to run the motor and I'm going to discharge it to the point where there's pretty much almost no power left in it. And then if I let it actually sit, the power comes back. And then I can run it again and let it sit again, the power comes back. So the idea is I got to get two of these. While one's running the motor, the other one's going to be recovering. So what I'm trying to do is I'm trying to figure out a way to decrease the interval time between the charge and discharge. If I can get the recharge faster than the discharge, I'm good. So I'm kind of working on that right now. Let's get her fired up here, I guess. Yeah, let's hook up the light. So I'm just using a light basically as a ballast so the system doesn't overload. Actually, really what it's doing is creating the negative resistance in the circuit that helps drive it. So I got it running now. Any questions, comments? The live chat is open. I can take anybody's questions. Got a couple people in. Hopefully more people will show up. It's kind of on the fly. I never really planned on doing this tonight, so we'll see what happens. See if more people show up. Yeah, it's the spark gap switch. So I don't know if you can see it. It is right here. It's an automotive 12-volt car relay switch. And I've advanced the timing on it, so it actually triggers a lot faster. And so what I did was I advanced the timing on it. It triggers faster. It's also completely isolated. So I've got this battery here, okay, that's running the trigger of the switch and also the proximity sensor from a 3D printer. That's picking up the flux from the magnet, spinning, triggers this. The reaction happens, goes through the transducer and out. So, see, you need the, okay, this is answering Grant. Grant, okay, yeah, you need the light on it. If you don't have the light on it, what's going to happen is that back spike is going to resonate in that relay, and it's going to burn it out. You have to give it a resistance in the circuit. There has to be a resistance in the circuit. So if you got the resistance in the circuit, the relay never overheats. And I put this thing through quite a bit of what do you call abuse, and I never have a problem with it. So yeah, that's what you want to do. So you always have a light hooked up as a ballast. I'm not really looking for the output right now. I know what I can get out of it. That's fine. What I'm working on right now is the dielectric. The dielectric of this capacitor bank. When you shut down the capacitor or you discharge it, You disconnect it, the power comes back. It's called dielectric absorption. It's known in regular electronics. Excuse me. So, um, okay, yeah, current. Good question. Okay, so the way, yeah, the Trigatron, mine's different. Okay, the motor I designed, the way it's designed, it takes very little current to run this motor. Number one, the size of the coil. The coil is crucial. I will not work with any pulse motor now that the coil is not bigger than 1 pound. 1 pound, 2 pounds, 3 pounds, 5 pounds, that's good. Anything under a pound, you're wasting your time. Because the amount of current that I draw from the battery into this is, I've got it as low, while in the Renegade, down to about 10 milliamps of current. All right. And that's enough to get the coil activated with the disruptive discharge and the transducer tied in together. Now you're creating a reactive power scenario. So the current of this motor is being generated in the coil. It's not coming from the battery. And that's where a lot of people don't understand. So that's the key to this motor. That's what makes this motor unique than any other motor out there. Is the current is not coming from the battery, it's being generated in the coil. If you do that, this is based on Joseph Newman's principle. He was using 460 volts DC at 50 milliamps, which, when it comes to current wise, that's nothing. But the voltage translated into the coil, which is, well, his was over, the big one he had was 7,000 pounds. That's a lot of coil. And that coil created a huge amount of current inside the coil, which was able to create the electromotive force that was necessary to move a 7,000 pound motor. So I suggest anybody who's into this stuff read about Joseph Newman's principle. The coil doesn't come from the battery input, it comes from the coil. That's where everything happens. The electromotive force is created in the coil. All you need is the voltage. That's it. You don't need current. You could go as, well, the Renegade's running at 10 milliamps. All right. So, let's see. Bigger coils certainly take longer to saturate. Not really. No. If you got a lot of voltage going in, like the Renegade, I got 50 volts going in. So, like, this thing's running on very small amount of power right now. I'm doing a certain type of test. In the Renegade, 50 volts is what you need input at 10 milliamps. That's very little watts, like 0.5, under 0.5 watts. But it's enough to activate that coil. The coil I have in the Renegade's 2 pounds. That's where the electromotive force is created in the coil. It's not coming from the battery. That separates my motor from everybody else's pulse motor out there, because it's based on the Newman principle. And Joseph Newman, he actually used a stator, make and break stator, or what do you call an electric motor? Got a brain fart here, trying to remember what you call it, the stator. So it's make and break, yeah, it makes sparks, but that's part of making the reaction happen, right? Yeah, and that's why Tesla worked with disruptive discharge. You got to get the voltage up. You get high voltage going through a coil, that's where the electromotive force is created. Don't rely on the power input to do it. Hi, Mike. How's it going? I've seen your live stream on Bernie's there. Really good. So, yeah. So, what I'm doing now in this experiment, I got the motor running. I got about, let me take a voltage reading here. So I got 2.3 volts in this capacitor bank right now. This will run probably, at the way I got it set up right now, probably about 4 hours. No problem on 2 volts. This motor will run at 0.6 volts, which is totally amazing. I don't know anybody else like other than lid motor. Okay, lid motor, but don't forget his inductor is nowhere near the size of this. His is like a 30, 40 turns. This thing's 1 pound. So I don't know anybody out there that has a pulse motor this scale running at 0.6 volts and still running. So that proves that the current is being, or the electromotive force is being created in the coil. As long as you got a voltage spike, that's when the reaction happens. That's where the reactive current happens. So, yeah. Oh yeah, I got more wheels made up. I water jetted these. So I got the new wheel there, sorry. These are designed by me. And then I got, oh yeah, here's the other topic I'm going to talk about too. Ceramic bearings. Highly recommend ceramic bearings. They cost a lot. Like these are like $14 each. $14 to $20 each. So they fit in the wheel. Precision cut. So they fit right in there perfectly. And they spin amazing. Like there's like, that's what this is running on right now. This has a ceramic bearing in it, and this thing has like very, very little resistance. So yeah, they are nice. I made 2 of them. I got 2. So one of my new ideas, what I want to come up with is make a pulse motor where I got counter rotating. One going clockwise, one going counterclockwise. I'm going to have a ring magnet on top, and it's going to create a toroidal flux. I've already done it. It creates hey Bernie, what's up? Yeah, so I'm going to try coming up with a pulse motor down the road where it's counter rotating, one clockwise, one counterclockwise. So I'm going to have a ring magnet on top, and it creates a toroidal spin. I put my EM meter beside it, and it was pulsating like crazy. I was getting a field probably about 6 inches away from the wheel. Yeah. So yeah, these are really sweet. I got to paint them and fix them up. Oh, you're doing a stream in an hour? Yeah, send me the link, Bernie. Maybe I'll hop on for a little while. It's Friday night. I can stay up a little later. So yeah. So work in progress. And these wheels they're not light. They're 0.38 thickness. Hold on, I've got my vernier here. Hold on. They are 0.38 inches. Yeah, but they got weight to it. They're heavy. I would say this one's about 400 grams, and like I'm putting right now, it's like 2 volts in this motor, and it spins it no problem. As long as you got that ceramic bearing. Ceramic bearing is where it's at. You have to have a ceramic bearing. It's totally essential. Also, I found too, having the resistance in the circuit, like either a light or whatever, or even a resistor, is what also helps drive the circuit, pull the current through. Because it's almost like you're creating, like, I hate to say shorting it out, but it's not. You're creating a negative resistance, and when you have the negative resistance, it pulls the current through the circuit. Now, if you do too much, you'll kill it. So you got to get that right ratio of the current. So I also got the steel bearings too. These are all right too, but you got to loosen them up. Skateboard bearings, they're good too. The size of these guys is the OD is 0.86 inches, so like 5/8, and the inside ID is 0.31 inches. So they're small. They're not very big, but they work well. When you get them loosened up, they actually have very little friction. So I'm finding more and more, the better the wheel, the better it spins. It helps. It definitely helps. So, any other questions, comments? Oh, one big topic, talking about this proximity sensor. Some people were saying I'm getting current from these. So I did research on the proximity sensor. They're saying there's a coil inside. There isn't. It's only a little steel plate with a sensor, and every time the magnet hits that sensor, that creates the trigger. So there is no magnetic field created in the proximity sensor, zero. So they were saying, well, because this sensor is being powered by a battery, that's where I'm getting the extra power. No, it's not, because there is no coil in it. It's just a little tiny little round plate attached to a sensor circuit board that picks up the field, and that's it. There's no assisting by it. So, let's see how many volts. 2.36 when I started. I got 2.16. Yeah, it's discharging, but very slow. But as you can see, it's spinning at a pretty good rate. The amount of current is like hardly anything. I got it as down as I got it as low as 20 milliamps. Actually, 10 milliamps if you want to get technical. Sensor field is AC. No, it's not AC. It's DC. Yeah, it's a proximity sensor from a 3D printer. There's no coil in that sensor at all. Well, let's see what you're saying. AC, not sure what frequency, but either way, well, it's a pulse DC. I would have to hook this up to my scope to actually find out, what the actual frequency. I think it's about 270 as far as I know, cycles right now. But, the transducer is creating a high spike. That's where the over unity gain is happening in the transducer. Nobody's using it. Why? I have no idea. If you hit a high voltage spike into a transducer, you're going to get 60 times back. So, and pretty much my motor can do that. Like this bulb here is 60 watts rated at, if I put it on a regular, even though it's an LED, when I put it up to the watt hour meter, it simulates 60, but it actually draws 6 watts. I can fully illuminate this with this motor for less than half a watt. I can light 6 watts perfectly. So I think it's over unity, personally. And yeah, I'm sticking to it. Yeah, I don't know, Bernie, if you're still watching, yeah, send me a link later so I can hop on if you're going to do a show. Any other questions? Yeah, this thing's discharging very, very slowly. This thing will run for a long time. Mm, just got the motor running here. The recovery on it, it's pretty good. Um, if I start the capacitor, say at 1.5 volts, I'll run the motor down to zero point 0.6 and I'll disconnect everything, let everything go to rest, and it will come back from zero point 0.6 volts up to zero point 0.7 volts within a few hours. It'll actually recover that voltage. It comes back. That's called the dielectric absorption. You can look it up. So, yeah, they're. Yeah, so the recovery is great. Like I can just let it sit for a few hours, fire it right back up, and it'll run again for another few hours without adding any more power to the system. That's um, yeah. You could like I could take the spike off of this and I can redirect one wire. I don't need two wires. I don't need a second wire. I take one off the positive and I can feed it back to the capacitor with a diode, and the diode's facing into the capacitor. The reason for it, you don't want that voltage going back into the resistance. You're going to send it one direction from the resistance to the capacitor. If you do that, you can make this run even longer. So, yes, but you only need one wire, which is actually pretty intriguing. A crystal battery? Oh god, that's gonna take a long time to develop. I'm working on that in the background. Haven't really posted much videos on that, but the crystal battery, like if you want to go back, what Hutchison was doing, it's all related to the transducer, the piezo transducer. So if I were going to make a crystal battery like Hutchison did, I would use barium titanate. Use the barium titanate, you watch what happens. Like even better than the Rochelle salts. I'd go buy a small portion of barium titanate, mix that up with your solution, create your crystal power cell exactly the way Hutchison and Laser Saber did his cell. You watch what happens. You're going to see something real interesting. I think I'm going to try looking around to see if I can get it. The barium titanate. That's probably got the highest yield gain in the piezoelectric effect. It's the key. I'm telling you, even I'm starting to find out now Tesla did a huge amount of research when he was in his 70s with the quartz crystal. And it wasn't really well known that he was working with that stuff, but he was. So he did some substantial amount of research with the quartz crystal. So yeah. So if he was working on that, yeah, I believe it. There's something special going on there. So I'm just going to head out for a smoke. I'm just going to focus it on the motor. It's going to keep running so you can just kind of see what's going on. I'll be right back. No, there's no. Oh, there's one person on. Any questions, comments? Live chat is open. Feel free. While I'm here, chat. I'm back. If you have any questions, comments, I'm online here. This is live. Feel free to ask any questions about my motor, how it works, what I'm using, anything, principle of how it works. Capacitor bank is running this now. It's only got about 1.7 volts in it. This thing will continue to run all the way down to about 0.6 volts. At this scale, it's pretty much impossible. Yeah, I can dump it in. All I have to do is attach one wire to the light, and I can dump it right back in. Right now, I'm not doing that. I want to discharge it, and then I want to see the dielectric absorption effect and see how much power will go back in. So I started at about 2.3 volts in here. After it runs out, then I'm going to yeah, the flyback's going into the load, which is the light. It doesn't have enough power to actually light it because I'm running with such little voltage. But that's not what I'm after right now. What I'm after is, after I detach this from the system, how much power is going to go back in without having to put power into it. That's what I want to see. It's called dielectric absorption. So that's what I'm looking, when I'm studying right now, that effect. It's well known in electronics, the dielectric absorption of the capacitor. So you can discharge it to the point where I got it down to 0.6 volts, and then by the next day when it went back to the capacitor, it was already back up to 1.75 volts. So it gained over 1 volt, 1.2 volts. Came back out of nowhere. It just came back into the capacitor bank, which is pretty cool. So I'm studying that effect, how I can exploit it and make it work for me. So once discharging and once recovering, then put it on a timer switch and flip it. And then that way the thing would just continue to run. And then if I can achieve that, then I scale it up. Now, one thing I do know about these capacitors, you get on Amazon, 16 volts, 500 farad. They have a balancing board on it. They have a resistor on it. So fill it right up to 16 volts. It discharges on its own because it's got a resistor built in it. So the ideal thing is to actually have a capacitor bank with no balance board, because I don't want it to discharge on its own. I want it to charge. But when you go down to like 0.6 volts, irregardless of the resistor on the balance board, it will recover. So I have another capacitor bank's 90 farad, has no balance board, and the thing recovers like crazy. So That's the idea. So how much can I exploit this dielectric absorption? So yeah, Bernie, send me the link to my email so I can jump on the live stream tonight with you. So yeah, it's still running. Right now the voltage is 1.68 volts, and it's still going good. And it's going down it's discharging very slowly. Yeah, simple is the best. Try to keep it so simple. Now, with the flyback, if I were going to take the flyback from the light and bring it back to the capacitor, what I would do, yeah, the balance board has bleeding resistors, yeah. So the ideal thing is to have a balance board or just get rid of the balance board altogether. You don't want it to bleed off, but if you're going to take the flyback from the light, all you need is one wire with the diode directed in the direction back to the capacitor, and this thing will run even longer. So a fast switching diode. Yeah, well, a lead acid battery also has that effect of recovering itself. I've noticed it with the Renegade, the big motor. The lead acid battery, if you discharge it a bit and then you let it sit for a couple hours, the power actually goes back. So yeah, the lead acid battery does exhibit dielectric rebound. See, the thing is, because my Renegade is running on only 10 milliamps. Hey Charlie, how's it going? Let's see, together in parallel standard car battery or wheelchair battery with a capacitor in parallel, yeah, even better. Any kind of deep cycle battery is like the best, like even like the cart batteries. Cart batteries have the extra charge in it. You know, the deep cycle is what you want. They're the best lead acid batteries that you can get, other than this battery here, which is a lithium iron phosphate battery. These things are amazing too. Now, this thing is starting to slow down quite a bit. You know, I want to know why. Slow it down. And one of my leads come off. Okay, actually, it went in the other direction. It starts spinning the other way. Haha. Cool. So what happened was it was spinning the other way and then it just bounced back. I don't know if you guys caught that. So now it's starting to spin the other direction. Now it's going the other direction now. So just to take a measurement reading, for some reason it gets to that certain point and then the motor looks like it's going to shut off, but I still have, see, now it's accelerating. It's actually going faster. It's actually accelerating now. Okay, so yeah, it's still got 1.61 volts in it. So it hit some kind of 0 point. I don't know what happened. I'm still trying to figure it out. The motor stopped and then bounced back and then went in the opposite direction. So now it's spinning again. And it's also accelerating. So that's another one, a question mark in my head. Why is it doing that? Any alternative propulsion? You know what? I gotta master the energy first. Without the energy, you can't get the propulsion. I just haven't really put much time into that. I thought I was going to get into that originally, but the energy thing was more practical at the time for me to do, because without the energy, you won't get the propulsion, right? So you got to master the energy first. And then some of the mysteries from the energy stuff will actually help develop the propulsion stuff. So that could be down the road. Who knows? Anyways, yeah, I cut some more wheels. I got ceramic bearings in it. I cut this on the water jet. So yeah, I got 2 of them. Identical wheels are 4.5-inch diameter, 380 thou thickness. Yeah, they're great. Really precision cut. Bearings are press fitted. So I got 2 of those done. So I gotta order some more of the ceramic bearings. That's what this wheel down here has, a ceramic bearing on it. So yeah. Hopefully Bernie will get online soon, and then we can do another live show on his channel, Crypto Alchemist. Probably going to end this stream soon. I've been going for, what have I been going here? I've been going, 1 hour. So I'm probably going to call it quits. I'll probably go on Bernie's channel later. So everybody give me a thumbs up before you go. And we'll see everybody soon.